Hello dear students, I hope you all are fine and feeling well. Before I continuously talk about today's presentation topic, I would want to share an appreciation message to my respected supervisor, Dr. Mao Shing, who gave me an opportunity to join his research team for my master degree. And believe me dear friends, I'm really excited for my master degree. I'm really excited for my master degree. And I'm 100% sure my selection will make you proud by proving myself a good researcher in field of petroleum engineering. I will try to fulfill your expectation and land successfully on your hopes. And my future aim is to become a good researcher, and it's only possible under your kind supervision. Thank you very much, dear professor, to make me eligible for that position. Thank you very much. Now let's talk about today's presentation topic. In today's presentation, I'm going to talk about the importance of PVT properties, different types of reservoir fluid, and then support my streamlined topic with the help of one example from the reservoir fluid, and it is PVT properties. So let's move toward the presentation. Before going to talk about the PVT properties, the question arises in mind that why PVT properties play a very vital role in petroleum engineering. Dear friends, PVT properties play a very vital role in reservoir engineering calculations. With the help of PVT properties, we can determine certain properties which are used in material balance equation, well testing analysis, numerical reservoir simulation, and many other parameters. So with the help of PVT properties, we are capable to determine those parameters which are useful in reservoir engineering calculation. Reservoir contains different types of fluid. It may be black oil, volatile oil, retrograde gas, wet gas, and dry gas. And it's very important for reservoir engineer to predict in the early life of reservoir. Why? Because it's the deciding factor in many parameters like fluid sampling, like type and size of surface equipment, which type of surface equipment we have to install on the surface. So we can predict it with the type of reservoir fluid which is present in the reservoir. Also we can calculation of original oil in place. How we calculate, when we know about the type of reservoir fluid, then we are able to get calculation about the original oil in place. And also we are capable to predict the oil and gas reserves as well as for depletion plane in EOR method. So these all parameters we are able to determine and take decision about these factors after getting information about the reservoir fluid. Dear student, if you observe that volume of oil in surface is less than the volume of oil in wellbore flow from the reservoir, it's just because of few parameters. But the pressure due to decrease in pressure in evolution of gas play very vital role in that. In order to understand that concept, first move toward the formation volume factor. So what is formation volume factor? So the volume of reservoir oil required to produce 1 barrel of oil in stock tank if the surface is known as formation volume factor. How much reservoir fluid will be required to produce 1 barrel of stock tank oil at the surface is known as formation volume factor. So when there is decrease in pressure, the evolution of gas starts. So if you talk about the graph of the formation volume factor, if you observe the graph of the formation volume factor, that is the point above the bubble point and that is the point below the bubble point. From initial condition till bubble point, that there is a decrease in pressure, expansions occur, no evolution of gas, so there is increase in formation volume factor. So when the bubble point reach, upon bubble point all gas get released, and when gas is released, just the huge particles remain in the reservoir and the formation volume factor value decreases. So from that point till that point, less amount of reservoir oil will be required to produce 1 barrel of stock tank at the surface. It after achieving a bubble point, when the gas start evolution and just the huge particle remain in the reservoir, a very multiple in a huge quantity of oil will be required to produce same 1 barrel of oil at the surface condition. Now what's the benefit of formation volume factor? So means when we multiply the formation volume factor with the stock tank, it gives an information that how much reservoir fluid will be required to produce stock tank at the surface. So it gives us information about that as well. It's very helpful. Means if we multiply formation volume factor with the stock tank oil, it gives us information that how much reservoir fluid will be required to produce 1 barrel of oil at the surface condition. Next property is solution gas oil ratio. Means how much gas is dissolved in the reservoir fluid. And simply, the quantity of gas dissolved in oil reservoir condition is called solution gas oil ratio. It's the amount of gas, or in the reverse we can also say that how much gas will be evolved from the reservoir fluid when we brought it to the surface is known as solution gas oil ratio. And it's also called dissolved gas oil or gas solubility. Means solution gas oil ratio means how much gas is dissolved in the reservoir fluid, or how much gas will be evolved from the reservoir when we brought it to the surface. Let's talk about the graph of the solution gas oil ratio. Means from the initial pressure till bubble point, if you observe that it remains constant. Why it remains constant? Means where there is decrease in pressure, gas is still present in the pore volume and no gas is evolved. So that's why its value remain constant till bubble point. But when the bubble point get achieved, there is a decrease in the solution gas oil ratio because the gas start evolving. And there's a two condition. One is saturated, one is undersaturated. Saturated condition mean when there's decrease in pressure, the gas start evolving. Undersaturated mean there's still capability to dissolve more gas. Mean that is the particular point, bubble point, when the first bubble arise. Means when the bubble point achieved, there's abruptly change in their volume. Why? All the gases start evolving and there's a just huge particles remain in the reservoir. And the next point is coefficient of viscosity. Mean there are two fluid, one is A and one is B. And B start resistance to the flow of fluid A. Means that the measurement of resistance to flow exerted by a fluid is known as coefficient of viscosity. Talk about the graph of the viscosity. Means above the bubble point and below the bubble point. Means above the bubble point there is slightly decrease. Until bubble point, after bubble point there is increase in the viscosity. Why? Because the gas start evolving, and when the gas evolve, just the huge particle remain in the reservoir and it offer very resistance to flow of the other reservoir fluid. So that's why its value increase after the bubble point. That's all for today's presentation. Thank you dear students for coming, and if you have any question you are free to ask. Thank you very much.